Hey, hello, Janis here. So in today's video, I would like to talk about different input modes and modalities of virtual reality and mixed reality and how we actually can control the experiences that we see through the lens of the headset. And I would like to use a hypothetical scenario of an application to make these points. So let's imagine that we want to create an application where you are creating sculptures out of blocks of marble and you want to reach wide audience, and let's go through all the different modes of control that you could use so users could actually chisel the blocks of marble and make wonderful sculptures, and what are the benefits and drawbacks of each one of the different input modes for virtual reality and mixed reality in an application like this. First of all, to determine the best way how to control an experience, we need to look at our users' needs and how they would like to interact with experiences. And then also we need to think about the market reach and accessibility and how many users we could potentially reach with each of the different input and control methods, as they vary quite a lot in terms of accessibility and also in terms of how expensive they are. So first of all, we need to look at what our users are expecting and actually how many users we want to reach, because each different input type and input method has different levels of accessibility and also different price points. And that is really important when you're building an application. I would like to start with one of the most commonly used input methods for virtual reality and mixed reality, and the first one that we had, which is a VR controller. So here you can see a controller of Meta Quest 3 headset. It's quite slick. They used to have rings around the controller edges, but now in the latest generation of headsets from all manufacturers, controllers look like this. They're quite handy and easy to use. The idea actually came from game controllers, so like this Xbox controller that you can hold in both hands. You can press buttons and triggers, and you have joysticks, and you can control games in gaming consoles. With VR controllers, one of the biggest benefits is that you actually are physically holding an item. You can feel more connected to different items you're holding in VR or MR experiences. And you have way more point precision, so the controllers are casting rays or directly can interact as your hands, and you can grab items and you can precisely point at things and you can move them around. So that's quite good. And they are quite easy to develop for. There are controller mappings. All the big game engines, they have SDKs for development, and that is definitely the most common way how we interact with XR at the moment. The potential drawbacks of controllers are, for example, they have batteries or they need charging, and then also there is a learning curve in terms of using them. So you have to learn the controls, you have to learn the controls of the particular application and watch what each button does or what each joystick press does in any direction. Another benefit of the controllers is that as you're holding controllers in both hands, it's very easy to manipulate different things even when you're not looking at them, because you still can feel the slight haptic feedback from the controllers. So you can program the application in the way that the controllers are giving you a slight haptic buzz whenever you are interacting with items or menus and actually touching things in VR, which is really good. And I will show you a couple of video examples of how those interactions work. So now let's move on to the next part of how we can control experiences in XR, and it is our hands. So hand tracking is becoming more common in all the headsets, and so for Meta Quest 2 and Meta Quest 3, for Apple Vision Pro, for Pico 4 and Pico 4 Ultra, and many other headsets, hand tracking is an interaction modality that is there. It is also reasonably easy to develop for and with, and grants you more freedom. So with our hands, we can interact with virtual objects with very high fidelity of finger movement. And actually, if we develop the experience right, we can get very realistic responses from objects and really natural ways of interactions. I would say one of the biggest drawbacks of using hand tracking is the precision of fine movements when you're interacting with objects indirectly, and I'll also show you a video example of this now. One of the biggest benefits of using hand tracking in experiences is that we already know how to use our hands, and it's really easy to onboard the user in the experience and application, and the tutorials can be way more light and shorter to get the users going and start experiencing and enjoying the application. And another big benefit is that you don't need any other devices, and you don't need charging controllers, for example, or like different machinery, which is really great, and once again, like really good for simpler applications and for mass market use, or also for more passive applications. For example, when you just like need to interact with some menus, or you need to like scroll through the content, maybe navigate yourself around, but you don't need to interact with things with a very high level of precision. Another of the drawbacks of hand tracking is that you have to put in more thought and development of the user experience in terms of different menus, and like all the menus you can map to buttons, you have to map them somewhere virtually and use different styles of hand menus and attachment, and that can be a bit more difficult to get the user experience right. And then another obvious drawback is that the user actually cannot feel anything. So for example, with controllers you can feel a slight haptic buzz. With hands you don't have any tactile feedback from what you're doing, and therefore you can and need to develop more of like visual and audio feedback for different user interactions. But once again, all of those are drawbacks that you can overcome, and for the right experience, the hands definitely is the right input method. Now let's move on to the next way of how we can interact with virtual worlds, which is a stylus or stylus pen. So Logitech has recently unveiled and released their stylus for interacting with objects in 3D space that's compatible with various headsets, and effectively it acts similar to, let's say, Apple Pencil or like a ballpoint pen that you can use to interact with objects in the 3D space. A really good thing about it is that it grants like a really nice precision of using the tool and like a point of interaction control you can have, and it's absolutely amazing for drawing or like sculpting in 3D space. But the drawback is that you still need to develop for another control method. Either would be the hand tracking or a controller in the other hand, and definitely the set of interactions is limited, but it's really good for some specific use cases, especially more in design. Now, another one of input methods is using haptic gloves. I don't have an example to show you at the moment, but I'll bring it up on the screen now. And the haptic gloves are effectively gloves that you wear in your hands, and they are packed with both sensors and also means of delivering feedback, being it haptic motors or an exoskeleton that actually stops your movement. And probably the most famous haptic gloves manufacturer at the moment is Haptics, and I had the privilege to work with them on one of the projects previously, just really cool technology. But the haptic gloves, especially more of the kinetic resistance ones with motors, are quite bulky and also still quite expensive. That being said, they give you the ability to stop the movement in midair and actually give you a real sense of touch when you're interacting with virtual objects in digital worlds, which is really good. And then there are some more lightweight haptic gloves which are also generating just this sense of touch, sense of pressure, a sense of buzz in your fingers. And they are really good to make the experiences more realistic. The drawbacks with haptic gloves are that you definitely need to do way more development for the experiences, and you need to add the whole haptic technology layer to your experiences. and also the experiences are more processing heavy and definitely require better hardware. I would say it's still possible to do some experiences with standalone XR, but to get the best experience with haptic gloves, most likely you will need a powerful PC and use PCVR solution. So another one of interaction methods is using haptic arms, or haptic robotic arms, or haptic input devices, and I can show you one on the screen now. And these are like robotic arms with motors inside that are providing resistance and force feedback, and it's called kinesthetic haptics. It is really cool technology to work with, and for the right use case it gives amazing user experience in terms of feeling the resistance of movement, feeling different textures of the objects that you're interacting with in the virtual world. And they are great for simulation where you need high precision, because also these devices are very precise, but the limiting factors are you have limited interaction area, and once again it's extra equipment. They are quite expensive and they need a lot more programming and coding for your experience to get it right. And because of that, they are quite expensive and bulky, and you most likely need a PC with them. Then it will be very difficult to get a mass market adoption for your application if you're using these devices. But they are really good for particular simulation use cases, and we use them a lot in Fundamental VR, where we are working on medical simulations and surgical simulations, let's say for ophthalmic or orthopedic surgery. So moving on, when we're looking at different ways how we can interact with experiences in XR, another way how to interact is actually to build your own input device. So for some particular simulations and experiences, like as you can see on the screen now, there is a welding torch that's a part of a VR simulation for welding. You can actually develop a custom controller, you can link it with your experience and actually get the right tool for the task that you need to do. And this can be very powerful and opens up a lot of opportunities for users to experience very realistic simulation. But once again, the drawback is that development of these tools is very expensive, and it requires a lot of development work, both software and hardware wise, to get it right. Another novel way how you can get feedback and do input into XR is using ultrasound haptics. So this would use a combination of hand tracking technology for input, and then also an ultrasound transducer array that can generate a sense of touch and sense of vibration midair. And this can be good for some XR experiences, but it's very limiting in terms of the area that you can interact and feel the haptic feedback. And also that the haptic feedback is effectively one-sided, but it can be very impactful experience for particular use cases. The drawbacks of this technology, once again, is that the interactions are very much one-sided, and the technology is still quite expensive and very difficult to develop for custom applications. Now let's go back to the idea of making this application where we want to teach users how to sculpt marble and make sculptures in virtual reality. And for the particular experience, to give the users the best ability to control what they're doing and also give them some feedback, I would personally choose to use VR controllers and map tools, let's say a mallet and a chisel, to the controllers, and then the users would be able to operate with a reasonably high degree of precision and also get some haptic feedback from the controllers themselves without limiting them to expensive hardware. And this way I could develop my application for most of the mainstream headsets, and I would also include an option of using hand tracking for a lighter and more introductory experience. And that would cover me for the part of market where people don't want to use controllers, and also for Apple Vision Pro, which ships without controllers. But in my mind, for experiences like this, and when you're wanting to reach a larger market audience, for example, like people who want to try out the experience without a lot of investment, and also for classroom education, this would be the best means of control. If I would be developing the application with different user type in mind, and if I would be developing it for, let's say, a university or a specific course for sculpting and doing simulations where I want to increase efficiency and not to waste material. In this case, it would be marble and potentially also space and time resource. Then I would go for haptic input devices and haptic arms, because they would grant like very good precision and real tactile feedback on what I'm doing. But that would very much limit the amount of users that I can have for the application. And although it would be giving a better user experience overall, it wouldn't have as big of a market reach. I hope you found this video insightful and you enjoyed the walkthrough of different input modalities and controls for XR and virtual and mixed reality. And I see you in the next one. Bye.